that when you expand this bracket, you simply arrive at what we have here. Are we together? Now, what will be the root of your given equation? Remember, the root will be of two answers. The first root will now be m plus 2 is equal to 0. So what is now your m? Your m will now be what? Your 2 is crossing an equality sign, so your m1 will now be what? Minus what? 2. Look at your m plus 3. M plus 3 is representing our m2. So your m2 here will simply be what? M plus what? 3 is equal to 0. Your m2 will simply be what? Plus 3 crossing an equality sign. It will be what? 0 minus what? 3, and that will give us what? Minus 3. So you've gotten the root of your equation to be minus 2 and what? Minus what? 3. What do you do next? The next thing you do is to get the final solution of your given equation. How do you do that? Check the root of your given equation. Are they the same? If they are the same, then you go over to the three cases you were given to check which of them suits the solution for our given equation. Now, looking at our cases, we can see that from our question we are given m1 to be what? M1 to be what? Minus 2. M2 to be what? Minus what? 3. Minus 2 and minus 3, they are not the same. So we have M1 is not the same or is not equal to what? M2. So what will be the solution to that equation? The solution to that equation will simply be what? Look at your cases. Your solution will be the first case here. So you simply have the solution to this equation to be what? A exponential raised to the power of what? M1. And M1 is what? Minus 2x plus what? B exponential minus what? 3x. And this will be the solution to our given what? Equation. Find the what? The final solution of your given equation. And what's your equation? Your equation is simply what? D square y over what? Dx square plus 10 dy over what? Dx, right? Plus what? 25, and this is equal to what? 0. What do you do? The first thing is to check if that equation is homogeneous. Simply write it down. Yes, your equation is what? Homogeneous. This is having an extra mark. You've given yourself an extra mark. The next thing to do is to get the auxiliary equation for your given what? Equation. So to get the auxiliary equation, we represent this as what? M square. So we have m square plus what? 10 multiplied by m, and this is having y here. So you have this to be what? Plus what? 25, and this will be equal to 0. So your auxiliary equation will now be y is equal to what? M square plus what? 10m plus 25. Are we together? So what you do is you simply what? Solve the quadratic equation you have there. What are the two numbers that when you add them, you are going to get 10, and when you multiply them, you are going to get what? 25. So we have 5 and 5. If you add 5 plus 5, that will give you 10. If you multiply 5 times what? 5, you will get what? 25. So you have this to be what? M plus what? 5, and you have m plus what? 5, such that when you expand, you simply arrive at what? Your given what? Quadratic what? Equation. So we can see that your parameters here are what? The same. So you can simply say that m here plus 5 is equal to what? 0. So m1 will now be what? Minus 5. M2 also will now be equal to what? Minus 5. So you can see that M1 here is equal to what? M2. So go back to your cases. What equation suits your given what? Differential equation? So you can see that M1 is equal to what? M2. So what is the solution? The solution for a given equation will now be what? Y is equal to a plus bx exponential raised to the power of what? M of what? X. So you go back to your given equation and you tell the examiner that the solution to our equation will simply be what? Y will now be equal to a plus what? Bx exponential raised to the power of what? Minus 5x. So this is the solution for our given what? Equation. Now let's take another example. Let's take another example to confirm if what we have here is the right what? Step and solution in solving these equations. If you have the square y here over what? Dx square plus, sorry, you have minus, so this is minus, so you have minus what? 4 dy over what? Dx plus 4 here, and this is equal to 0. What do? The first thing is to check if it's homogeneous. Yes, it is homogeneous because it is equated to what? 0. What's the second thing? To get the auxiliary equation for our given ordinary differential equation. Now, your auxiliary equation will now be what? M squared minus 4m plus what? 4 here. So this is 4y. So plus what? 4, and this will be 0. So your auxiliary equation will now be y is equal to what? M squared minus 4m plus what? 4. Are we together? So solving the quadratic equation, look for those two numbers that when you add them, you are going to get what? Minus 4. And when you multiply those two numbers, you are going to get what? 4. What are those numbers? Minus 2 and what? Minus 2. So if you multiply minus 2, that will give you, if you multiply minus 2 by 2, you are going to get what? 4. And if you add minus 2 plus what? Minus 2, and that will give you what? Minus 4. So those two numbers are what? M minus 2 and what? M minus what? 2. And this is equal to what? 0. Such that when you expand this bracket, you simply arrive at what? M squared minus 4m plus what? 4. So what you simply have here is what? M minus 2, and this is equal to 0. So your M1 here will be what? 2. Because plus minus 2 is crossing an equality sign, which is what? Plus 2. And you have M2 to be the same as what? M2 will still be the same as what? Plus what? 2. Such that you have that M1 will now be equal to what? M2. Now what do you have there? Your given final solution for your ordinary differential equation will now be what? A exponential A what? A. What's your equation? Go back to your cases there. You simply have A plus BX. So we have here to be, what you simply have here will now be what? A plus what? A plus what? BX, all in what? Exponential raised to the power of what? Mx. So your M here is what? 2. So you have 2 of what? X. Are we together? So basically, I've simply given you some equations that you can see when you are given to get your what? Case 1 and case 2. Let's take some complex what? Root equation. Let's take an example for complex root equation. If we are given an equation, if we are asked to find the solution for your given equation, and you are given that what? You have d square x over what? You simply have d square y over what? Dx square, right? And d square y over dx square plus what? 4 dy over what? Dx. And this is what? Plus what? 9y, and this is equal to 0. Now, if we are asked to get the what? The final solution to our second ordinary differential equation, what will it simply be? The first thing is to always check if that equation is homogeneous or not. Looking at our equation, we can see that the equation is what? Homogeneous, because it is equated to what? 0. That's the first thing you do. After confirming that your equation is homogeneous, get the what? Auxiliary equation of your given what? Second ODE. Now, to get the auxiliary equation, we already know that our auxiliary equation is always given to be what? M squared plus what? 4m, right? Plus what? 9, and this is 0. So your auxiliary equation, which is y, will now be equal to what? M squared plus 4m plus what? 9. Are we together? So what do? The next thing is to solve your what? Equation quadratically. To solve this quadratically, either you what? Factorize, or better still, you what? Use your what? Quadratic formula. If we are to factorize, what do you think we are going to get? Look for two numbers that when you multiply, you are going to get what? 9. And when you add those numbers, you are going to get what? 4. Can you get any number? If you have 3 and 3, 3 times 3 is 9, 3 plus 3 is 6, and it's not 4. Are we together? So there are those, we cannot get any number of that nature. So what we do is, here you simply apply your what? Your quadratic formula. What's your quadratic formula? Recall that our quadratic formula is given to be what? Minus b plus minus square root of what? B square minus what? 4ac divided by what? 2a. Are we together? Now what you do is, remember from your given root, if you have b here, what's your b? Your b is 4, so you have your a here to be what? 1. The coefficient here is 1. The coefficient here is 4. And what do you have here as your c? 9. So you have your b here to be what? 4. And you now have your c here to be what? 9. Such that you simply use all these parameters in your equation to represent with these what? Values here. Are we together? So if we do that, we'll simply have our quadratic equation to be given as what? Minus 4 plus or minus square root of what? 4 square minus 4 multiplied by what? A is 1. So you have 1 times what? C is what? 9. So this is 9, right? And this will be what? Divided by what? This will be divided by 2a. And 2a, a is what? 1. So you have what? 2. If you simplify this, we'll simply have this to be what? Minus 4 plus minus square root. Remember, 4 square is what? 16, right? So this is what? 16. Now you have minus here, which is what we have here. You have 4 times 1 is 4 multiplied by 9, and that is what? 36. So you have 36 here divided by what? 2. Are we together? Now if you punch your calculator, 16 divided by 36, that will give you what? 20. So what you simply have there will simply be what? Minus 4 plus or minus square root of what? Minus 20, right? So since you have minus 20 divided by what? 2. Remember, you have what? Minus 20. And what are you seeing here? Root. So what is this telling you? Complex what? Number. Now how can we simplify this minus 20 here? We can also simplify when we have square root of minus 20. Square root of minus 20 can also be what? Square root of what? 4, right? Plus, you can have square root of 4 times what? 20, which is 5. So we have 5. 5 times 4 is 20 times what? Minus 1. And that will give you what? Minus 20. Are we together? Now, if you are splitting this, then you are going to have square root of 4 times what? Square root of what? 5. This is minus 5. Are we together? So this is what? Minus 5 because of your what? Your minus 1 here. What is your square root of 4? Square root of 4 is what? 2. And you have this to be what? Root what? Minus what? 5. Are we together? And what's root minus 5? Root minus 5 will simply tell you that this is a what? A complex what? Root. Are we together? So root minus 5 can also be written as what? 2 root what? 5i. Are we together? Telling you that you have a complex root. So if you take this back to your given equation, you simply have minus 4 divided by what? 2 plus or minus 2 root what? 5i divided by 2. Are we together? So what do? Your 2 here will cancel out 2 here. 4 divided by 2 is actually what? 2. So you have this to be what? Minus 2 plus or minus what? Square root of 5i. Are we together? So you've gotten your what? Your complex root. What do? Since we've gotten our complex root to be what? minus 2 plus or what? Plus or minus square root of what? 5i. Recall that from our case 1 here, we have that when m1 is equal to what? When m1 is not equal to what? M2, then we'll have our case 1 to be what? Given to be y is equal to a exponential m1 plus what? B exponential m2 and x here. Are we together? But in this case, we are having a complex root. So since we are having a complex root, what do? We recall our given equation for our complex root to be what? M is equal to alpha plus or minus I beta. Are we together? Such that what you have at the right hand side will now be beta. What you have here will now be what? Alpha. So if you recall the equation for complex root, you will simply have that m is equal to what? Alpha plus or minus I beta. Are we together? Where our alpha is equal to what? Minus 2, while your beta is now equal to what? Square root of what? 5. So if you represent this with our given equation, we'll simply have that the final solution for your given equation will now be y is equal to, go back to your equation, what are you seeing? Exponential raised to the power of what? Alpha x. So you simply have here to be what? Exponential raised to the power of what? Alpha, and alpha is minus 2x into a, right? So you have your a, what do you have here? Cos beta x. So you have cos beta x. What's your beta? Your beta there is simply what? Your beta there is simply a cos what? Beta, which is what? Square root of what? 5, plus what's the next one? We have b sine beta x. So you have what? B sine beta x. So you have here to be what? B sine beta, which is what? Root what? 5 of what? X. Are we together? So this is the final solution for our given what? Equation. Remember, this equation was given to be a complex root. So when you have a complex root and you want to recall the final solution for that equation, you recall the what? The characteristics equations that they've been given to you, which is your case 1, your case 2, and your what? Your case 3. Now let's take one more example. So if we're given this equation and we are asked to get the final solution to this equation, what do? The first thing I said you should do is always check your equation if it's homogeneous. Looking at the equation, it is homogeneous because it is equated to what? 0. So since this equation is equated to 0, we can say that our equation is what? Homogeneous. That's the first thing you do. Now, since your equation is homogeneous, the next thing to consider is the auxiliary equation for this given equation here. The auxiliary equation will simply be what? The auxiliary equation from what we've been doing so far will simply be what? M squared, right? Minus 2 what? M plus what? 10, and this will be equal to 0. So therefore, your y will now be equal to what? M squared, right? Minus what? 2m plus what? 10, and this will be equal to 0, or better still, you can still leave your equation that way. Now if you leave your equation that way, your interest is to look at your equation if it's having the form of a quadratic equation. Looking at our equation, the equation is in the form of what? A quadratic equation. So what do? You apply your factorization method, or better still, you apply your what? Your quadratic what? Formula. Look at this equation. If we were to apply your factorization method, then we are going to look for two numbers that when we multiply, we are going to get 10, and when we add them, we are going to get what? Minus 2. What are those numbers? We can see that if we have 5 and 2, if we multiply 5 times 2, it will be 10. But what if you now subtract 5 minus 2? Will that give you 2? No. So there are no numbers of that nature, or there are no numbers that will suit what? That particular what? Concept. So what you simply do is to apply your what? Your quadratic what? Formula. And what's your quadratic formula? Your quadratic formula is simply what? Minus b plus or minus square root of what? B square minus 4ac divided by what? 2a. Are we together? Now from this place we can get our given parameters, which are what? A, B, and C, such that we just carry the values, input into the formula, and we get our what? Our root for the equation. Now what's your A here? From your equation, your A is having what? A coefficient of 1. So you have 1 here. What's your B? Your B is actually what? Minus 2. While your C is what? Your C is what? 10. Are we together? So if you do that and you input those values into our given formula, we'll simply have that minus B, right? So minus B is what? B is minus 2. So we'll simply have minus 2 plus or minus square root, right, of b square, which is what? Minus 2 square, right? And minus 2 square is actually what? 4. But that notwithstanding, we have minus 4 times what? 4 times 1 times what? 10. Are we together? And this will be dividing what? 2 times what? 1. Are we together? Now if you do that, from our bracket here, we'll simply have minus 2 plus or minus. What we have inside this bracket will simply be what? 2 raised to the power of 2 is 4. So what you have here will simply be what? 4 minus 4 times 1 is what? 4. 4 times 10 is what? 40. So minus 40 divided by what? 2. Are we together? Now what do? 4 minus 40, that will give us what? Minus 36. So what you have here will simply be what? Minus 2 plus or minus square root of what? Minus what? 36 divided by what? 2. We can also simplify this by writing what we have here to be what? What we have here will simply be equal to what? Minus 2 divided by 2 plus or minus, remember this is what? Square root of what? Minus 36. And when you have your minus inside your root, that tells you that it is a complex what? Number. Are we together? So since this is a complex number and is dividing by 2, we can get the square root of 36. What's the square root of 36? The square root of 36 is actually what? 6. Are we together? So 2 here into 2 here, they will simply what? Wash out, and you'll be left with what? Minus 1 plus or minus. Square root of 36 is 6. And remember, you have minus inside. That's telling you that it is a complex what? It is a complex number. So since you have this as a complex number, this will now be what? 6 what? I divided by what? 2. Remember, 6 can divide 2, and that will give us 3. So your final root will simply be what? Minus 1 plus or minus 3i. Are we together? So you can see that this is a complex what? This is a complex root. So what you simply do is you both go back to your characteristics equation and recall the equations given to you. You were given that from the first equation here, you simply have that for your case 3, you have a complex root equation. And what's the equation for your complex root? Your complex root equation simply says when you have m is equal to alpha plus or minus I beta, your alpha will simply be what? Your alpha here from our equation, our alpha will simply be what? Minus what? 1. So you have from your equation, your alpha will be equal to what? Minus 1, while our beta will be equal to what? Confirm your beta. Your beta will be equal to what? 3. Are we together? So you have your beta to be equal to what? 3. So what will be the solution to our equation? The solution to our equation will simply be what? Y is equal to exponential alpha x into a cos what? Beta of x plus b sine what? B sine beta of what? X. Are we together? So if we have this, and if we want to impute our alpha and beta, we'll simply have our given equation to be equal to what? Exponential raised to the power of, what's our beta? What's our alpha? Alpha is -1, so we can leave it as what? Minus what? X into a cos what? Beta. What's beta? 3. So you have 3x bracket plus what? B sine what? Sine 3x. Are we together? So this will be the equation you are asked to calculate for. What you help me do is, after the class, solve the square y over what? Dx square plus 8 what? 8 dy over dx plus what? 16y. And this will be equal to what? 0. So what you do is, you get the solution to this equation and drop the root of your equations on the comment section. From what we are given here, we are actually asked to what? To find the general solution for our given what? Second ordinary differential what? Equation. Now the first thing you do is to ask yourself, what is our general solution? Now your general solution is actually given as, your general solution is actually given to be what? CF plus what? P what? I. Or better still, you can have what? YCF plus what? YPI. Where we know that our CF is what we call our complementary what? Function, while your PI is called what? Your particular what? Integral. So when you are given an equation of this nature, the first thing to do is to get the complementary function of this equation. After getting the complementary function, use your complementary function, deduce an equation with your particular what? Integral through your complementary function. Impute them together, add them together, and you get what? The general solution of that what? Particular equation given to you. Now, let's solve this. The first thing you do first is to check your equation, to check if your equation is homogeneous or not. You always tell your examiner that, oh, this equation is homogeneous, oh, this equation is not what? Homogeneous. From what we have here, we can see that our given equation here is not what? Homogeneous. Why is it not homogeneous? Because it is not equated to what? 0. So your given equation here is what? Non-homogeneous. Non-what? Homogeneous. So what you have here is what? A non-homogeneous what? Equation. Non-homogeneous what? Equation. Reason being that it is not equated to what? 0. Are we together? That's why it is non-homogeneous. Had it been it is equated to 0, then this equation is what? Homogeneous. Are we together? Now, after considering that your equation is non-homogeneous, the first thing you do is to get the auxiliary equation from your given what? Differential what? Equation. Now remember, when we want to get our auxiliary equation, we always what? Assume. Are we together? Now, if you want to get your auxiliary equation, we assume that m square is equal to what? D square y over what? Dx square. We also assume that what? M is equal to what? Dy over what? Dx. Are we together? And finally, we assume that partial of if we differentiate 6y with respect to what? With respect to y, we'll simply have what? 6. Are we together? So we are assuming that your 6y here will be equal to what? 6. Are we together? So your new equation from your auxiliary equation will simply be what? Y will be equal to m square plus what? Remember, what you have there, is it plus or minus? We'll simply have minus 5. So what you have here will simply be what? Minus. So take down the correction. Here will simply be what? Minus what? 5x. Is it 5x? You simply have 5 what? M, not x. Remember, your dy over dx is equal to what? M. So what you have here will simply be what? 5 what? 5m, right? And that will be what? Plus 6. So you have plus 6 here. So this is your auxiliary what? Equation. After getting your auxiliary equation, we can see that our auxiliary equation is having the form of a quadratic what? Equation. Are we together? So what you simply do is you solve the equation quadratically. Solving the equation quadratically, we are going to equate this with what? 0. So you simply have m square minus what? 5m plus what? 6, and this will be equal to what? 0. We can see that we now have what? A quadratic what? Equation. What's our interest when we are considering quadratic equation? Our interest is to consider what? The root of our given equation. And the root of our given equation is always what? In 2. Why I said in 2 is because you are going to get 2 answers as your root. Are we together? And that will tell you that you are going to get m1 and what? m2. Are we together? Now, what do you do? For you to do that is the concept behind quadratic equation is either you use factorization method or basically use your what? Your quadratic formula in solving this problem. Let's use our factorization method because we can factor out something here. Factoring out a value here, we can factor out minus what? Minus 2 and minus 3. Why do we say minus 2 and minus 3? The concept is very simple. Look for two numbers that when you add them, you get minus 5, and when you multiply them, you get what? 6. Those numbers are what? Minus 2 and what? Minus what? 3. So basically, using factorization method, you simply have this to be what? M minus 2, and this will be what? M minus what? 3, and this will be equal to 0. Such that when you expand this bracket, you simply arrive at what? This particular what? Equation. Are we together? But remember, our interest is the root of the equation, which is what? m1 and m2. So from what we have here, we can equate m minus 2 to be equal to 0, and we get our m1 here to be what? 2. Because your minus 2 is crossing what? An equality sign, which is what? Plus 2. So you have your m2 here. m2 will simply be what? M minus what? 3 equal to 0. And your m2 will be equal to what? 3, because minus 3 will be crossing an equality sign. Now you can see that your m1 is equal to what? 2, and your m2 is equal to what? 3. Looking at these two values, are they the same? No. So we can say that m1 is not equal to what? m2. And what's the concept behind m1 not equal to m2? The concept is actually y will simply be what? A exponential m1x plus what? B exponential m2x. This is the concept. So if you apply that, you simply have that y will now be equal to what? A exponential raised to the power of, what is your m1? Your m1 is 2, right? So you have 2x plus b exponential raised to the power of m2 is what? 3. So you have 3x here. So this is your what? Your complementary what? Function of your given what? Equation. Since you've gotten your complementary function of your given equation, what do? You simply get the what? The particular what? Integral of your equation, which is what? Pi. Now I told you now to get your pi, you bring out an equation that is similar to your given what? Equation, which is what? Your auxiliary equation. Bring out an equation that is similar to your auxiliary equation. Now we can deduce an equation that is similar to our auxiliary equation. So you can take down for your particular integral, for your what? Particular what? Integral. We can deduce an equation that looks like our auxiliary equation, and we say that what? Y will be equal to what? Cx squared plus what? Dx plus what? E. This equation is similar to our auxiliary equation. Let's confirm. Remember, auxiliary equation is having a square here. What are we seeing here? We are seeing what? X here. What are we seeing here? Our auxiliary equation is having what? M here. And we are seeing a constant here. And that constant for your particular integral for your given equation is now what? E. The next thing is to get the differential for your each, to get the differential, to differentiate with respect to what? X here. Now if you differentiate this with respect to x, if you differentiate this equation with respect to x, you simply have that dy over what? Dx will simply be what? 2cx plus what? D. Are we together? Now you've differentiated this equation with respect to x. What do you do next? You differentiate again. If you are differentiating again, you simply have that this square y over what? Dx square, and that will give you what? 2c. Are we together? So what do you do? Since you've gotten your dy over dx and you've gotten your d square y over what? Dx square, what you do is you pick this equation and you impute it back into our given equation, which was what? D square y over dx square minus 5 dy over dx plus 6y, and that equation will be equal to x square. Are we together? So what we simply do is you are picking these values here and you are replacing it into this equation. Are we together? But recall that we were given our given equation. Our given equation was what? D square y over what? Dx square minus 5 dy over what? Dx plus 6y, and this is equal to x square. So what you are doing is anywhere you see d square y over what? Dx square, you are imputing what? 2cx plus d. Are we together? So that will give us, from what we have here, we'll simply have that your d square y over dx square will simply be what? 2cx plus what? D minus 5. What is now this dy over dx? Dy over dx, what we have here is 2c. So this is 2c, not 2cx. So this is 2c, right? Then we have plus 5. This is 5. And what is your dy over dx? Your dy over dx, remember this is minus, right? So you have minus here, minus 5, which is this, and you have dy over what? Dx. What's dy over dx? 2cx plus d. So this will be in bracket 2cx plus what? D. That's what we have there. And that will be our close bracket plus, we have plus here. Remember, this is 6y. And what's your y? Your y is what? Cx squared. So you have 6 brackets. Your y is now what? Cx squared plus what? Dx plus what? E. And this equation is equal to x squared, which is showing us that our equation is what? Non-homogeneous. So what we simply do is we can expand from what we have here. So if we expand from what we have there, remember this is what? 2c, right? Minus into 2cx, we'll have 10, right? So that will be 10. 5 times 2 is 10. So you have 10cx minus 5 times d here, and that will give you what? 5d. Plus you expand this. If we expand this, we'll simply have that 6 is multiplying all through. And if 6 is multiplying all through, that will give us 6cx squared plus what? 6dx plus 6 what? E. And this will be equal to what? X squared. Now, we can still simplify this further. Simplifying this further, we can take those like terms one side. If you take those like terms one side, we can take 6cx squared to as our initial. So if we do that, we'll simply have this to be what? We'll simply have this to be 6cx squared minus remember this is what? Cx, and this is what? 6dx. We can put them together. Then this we'll simply have this to be equating x outside. We'll have x outside, and we'll have 10c, which is this, and this will be what? Plus what? 6d. 6 what? D. Are we together? Now what are we now left with? We are now left with the remaining values, which are what? 2c, 6e, right? And what? 5d. So this will be plus 2c minus what? 5d plus what? 6 what? E, and this will be equal to what? X squared. Are we done? No, we are not done. So since we are not done, the next thing we have to do is to compare. Comparing, we want to compare so we can get the value for what? C, D, and what? E. Now, comparing from our first value there, if we are comparing our first value, which is 6x squared, if we want to compare our first value, we'll simply have that 6c will be equal to what? 1. So what do you think our c will be? Our c here will simply be what? 1 divided by what? 6, because your 6 will be dividing all through, and you have what? 1 divided by what? 6. Are we together? Now let's go to the next parameter here. The next parameter we are seeing there is what? 10c plus what? 6 what? D. And we can equate this to what? 0. So if we equate this to 0, remember we are comparing. If we equate this to 0, we already know what is what? C, right? And we know that C is what? 1 over 6. Remember, our interest is to get what D is. So your D here will simply be what? We are taking this to the other side of your equation. If you do that, this will simply be what? 10c, and c is 1 over 6. So 1 divided by 6 divided by, remember you'll be dividing both sides with what? 6. So you simply have that your D, if you punch your calculator, your D will be 5 divided by what? 18. Confirm with your calculator and drop a thumbs up if the answers are what? Correct on the comment section. The next thing is to get what is E. Comparing to get what is E. Now if you want to compare to get what is E, remember E is what? 2c minus 5d plus what? 6e. So what you have here will be what? 2c minus what? 5d plus what? 6e, and we are equating this to what? 0, because we want to compare. If we are comparing, our interest is to get what is E, right? So all other values will be crossing an equality sign to the other side. Or better still, we can still represent this to be 2 into C is 1 over 6, right? And this will be minus what? 5. And D is what? We know D to be what? What's our D? Remember, we calculated D to be what? 5 over 18. So we have D here to be what? 5 over what? 18, right? And this is in brackets plus 6 what? E, and this will be equal to what? 0. Now, our interest to get is to get what E is. Are we together? So to get what E is, we can take this to the other side of our equation. We can take everything here to the other side of your equation. Or better still, you can still punch your calculator. What is this value here? Remember, to get your E, we are dividing all through here with what? We are dividing all through here with we are dividing all through with what? We are dividing all through with 6. Are we together? So to get your E, we will simply have that. So what you have here, if you punch your calculator, you have that 2 of 1 over 6 minus 5 of what? 5 over 8. This will give you minus what? 19 over what? 18 plus what? 6 what? E. And this will be equal to 0. So what you simply have is 6e is equal to 19 over what? 18, because this is crossing an equality sign. So what will you simply have? You simply have this to be what? E, and E will be dividing what? E will be dividing what? 6. E here will be dividing what? 6. Are we together? Now, if you punch your calculator, you can simply have this to be written as 19 over what? 18 times 1 over what? 6. Are we together? Now, if you do that, you simply have that your E here will be equal to what? Minus 19. Remember, that minus has been cancelled out, so we have plus 19 over what? 108. That's what I have on my calculator. Get your answers and drop it on the comment section. So what you do next is, since you've gotten that your E is equal to what? 19 over what? 108. You simply get your, you simply apply this back to this equation. Since you've gotten E to be 19 over 108, we simply take the values of our given parameters, which are C, D, E, to our given equation. Now remember, your given equation was what we have here. This was our given equation, right? So since we are given this, and we know that for our PI equation is what we have here. This is our PI equation. So you can write this to be YPI. So since we've gotten the values for C, D, and E, we are imputing those values into this equation here. So if we do that, we know that YPI will be equal to, what's the value we have there? What's the equation we have there? CX squared. So this is CX squared, right? And CX squared plus what? So we have CX squared plus DX plus E. So this is CX squared plus what? DX plus what? E. And this is equal to, we already know our C. What's our C? Our C was 1 over 6. So this is 1 divided by 6 of what? X squared plus what? What's your D? Your D was given to be 15. 15 over 18. So you have your D there to be what? 15 divided by what? 18x plus what? What's your E? Your E was now finally given to be 19 divided by what? 108. So you simply have that your E is what? 19 divided by what? 108. So what you simply do is we rearrange this equation. And if you rearrange this equation, you simply have x squared divided by 6 plus what? 15x divided by what? 18 plus 19 divided by 108. So simply you've gotten the equation for, you've gotten your answer for your what? Your particular what? Integral. And you've also gotten your answer for your what? Your what? You've also gotten your answer for your what? Complementary function, which is what? A exponential 2x plus what? B exponential what? 3x. So what you do is you impute these values into your general solution. And your general solution, remember that your general solution is given to be what? CF plus what? PI. So what's your CF? Your CF is simply what? Your CF was calculated to be, your CF was calculated to be what? A exponential 2x. So you have A exponential, you have A exponential what? 2x plus what? B exponential what? 3x plus, what's now your PI? Your PI is now given to be what? What is this? You have x squared divided by 6. So this is x squared divided by what? 6 plus 15x divided by what? 18 plus what? 19 divided by what? 108. So this is the general solution for your given what? Integral. And this is what you are asked to what? To calculate for. Is that not simple? So you've simply gotten the general solution for our given integral, which was what? Was given to be what? D square y over what? Dx square minus what? 5 dy over dx plus 6y, and that is equal to what? X squared. So from the above question, we are actually given to find the general solution for this particular equation. Look at our equation. Our equation is simply having what? D square y over what? Dx square minus 5 dy over dx plus 6y, and that is equal to what? 2 sine 4x. Are we together? So basically this question is having a trig function, which is a what? Sine 4x. Are we together? So the first thing you do is to check your equation if it's homogeneous or not. We can see that our equation is what? Non-homogeneous, because it is not equated to what? 0. So this is a non-homogeneous what? Equation. After doing that, the next thing is to consider our given equation. If we are considering our given equation, you recall your what? Your auxiliary equation. For you to find the auxiliary equation, you always what? Assume. So since we want to get our auxiliary equation, we are going to assume that the y over the square y over the x square will be equal to what? M square. The y over what? The x will be equal to what? M. And 6y there will be equal to what? 6. Are we together? So if we do that, we'll simply have that m square, right, minus what? 5 what? M plus what? 6 will be equal to what? 0. Looking at this equation, this is a quadratic equation. We know that our m1 is simply what? Our m1 is simply 2, and our m what? Our m2 will be simply what? Our m2 will be what? 3. Now, what is the complementary what? Function of our given equation? The complementary function of this equation will simply be what? YCF will now be equal to a exponential raised to the power of what? 2x plus what? B exponential raised to the power of what? 3x. This is the complementary function of our given what? Auxiliary what? Equation. The next thing is to get your particular what? Integral from your given equation. Are we together? Now, I told you that for you to get your particular integral, you introduce an equation that is similar to the equation given to us. Remember, we are given a trig function. So the equation we are going to introduce now will be having what? A trig function, and it will be similar to what we have here. Now, if you want to introduce an equation for your particular integral, we'll simply have that your ypi, which is your particular what? Integral, your ypi will simply be equal to what? A cos what? 4x plus what? B sine what? 4x, such that your equation will be having a similar equation with your what? Equation, your differential equation given to you. Are we together? And remember, our equation was a homogeneous function, and the homogeneous function was what? 2 sine what? 4x. So since our interest is our 4x, we are going to introduce an equation for your particular integral that will be having a trig function with respect to what? 4x. That was why we introduced this particular what? Integral what? Equation to be what? A cos 4x plus what? B sine what? 4x. Are we together? Now, after doing that, what do you do first? The first thing is to differentiate. Why are we differentiating? We are differentiating such that we can achieve a balanced equation as our given what? Differential equation. So we are going to differentiate this equation twice. So we are going to differentiate the first one. We are differentiating the first one, which is what? The y over what? Dx. If you differentiate this equation, dy over dx, if you differentiate what you have here will simply be what? Minus 4. If you differentiate cos, you will simply have what? Minus sine, which is what? Sine 4x plus If you differentiate what you have here, you simply have what? 4b, right? Cos what? 4x. Are we together? Now we've differentiated once. Let's differentiate again to achieve a balanced equation as our given what? Equation here. Are we together? So if we do that, we'll simply have that the square y over what? Dx square will simply be equal to, want to differentiate this again. If you are differentiating this again, this will simply give you what? If you differentiate 4x here, you will simply have 4, right? So you have 4 multiplied by 4 here, and that will give you what? 16. So this will give you what? Minus what? 16a. If you differentiate sign, you have what? Cos. So you have cos 4x plus what? 4b cos what? 4x. If you differentiate, you simply have this to be what? Minus what? 16. Because 4 is outside, so we have 4 times 4 is 16. B, right? Sine what? Sine 4x. So if we simplify this further, we'll simply have this to be minus 16a cos what? 4x minus, you cancel out because minus times plus is minus. So you have minus 16b sine what? 4x. So you can see that you've gotten a balanced equation as our given what? Differential what? Equation. What do you do next? You pick this equation and you replace it with wherever we are seeing our what? Given equation to be what? The square y over dx square minus 5 dy over dx plus what? 6, and that will be equal to what? 2 sine what? 4x. Are we together? So if we do that, we'll simply have our balanced equation to be, the first thing you need to do is to get what is the square y over what? Dx square. We have that to be what? Minus 16. So you have minus 16a cos 4x. This will be very long, so take it bit by bit. Minus what? 16b sine what? 4x. Are we together? The next thing is, go back to your equation. We are given minus 5 dy over dx. So you have minus 5, right? So you have minus 5 here. What's dy over dx? Dy over dx was simply what? Minus 4a sine what? 4x. So we are picking this into that equation. We'll simply have minus what? 4a sine what? A sine 4x plus 4b cos what? 4x. Are we together? Now, what's the next thing we are going to do? Remember, your equation is given to have what? Plus 6y. So what's your plus 6y? You simply have this to be what? Plus 6. And what's your y? Your y was given to be what? A what? A cos what? 4x plus what? B sine 4x. Are we together? So this is what you have, and this is equal to what? 2 sine what? 4x. Are we together? So what you simply do is you simplify your right hand side, which is what you have here. Are we together? Simplifying our right hand side, we can collect like terms, and if we collect like terms, we can group. What you do is you group terms by what? Cos 4x and what? Sine 4x. So we are grouping cos 4x one side, we are grouping what? Sine 4x one side. Now if you do that, you simply have that what you have here will be minus 16a. This is having cos 4x. So you have minus 16a minus 20b plus what? 6a, and these are the values for what? Cos 4x. Confirm that. What's the next one? The next one is we are grouping for sine x. So this will be minus 16 what? We'll simply have 16b. So we have 16b. So this is 16b plus what? 20a plus what? 6 what? B. And this is for what? Sine 4x. Are we done? No, we are not done. Since we've grouped for your cos 4x and your what sin 4x, we can still simplify further from what we are seeing here. And if we simplify further, we'll simply have that what you have there will be equal to what? Minus 10a minus what? 20 what? b cos 4x. And we're still simplifying. So what can we factor out here? We can still factor out plus 20a. So what we have here will simply be what? Plus what? Bracket 20a minus what? 10b. And this is for what? Sine 4x. That's what we have. And this is equal to what? 2 sine what? 2 sine 4x. That's what we have here. And this is equated to what? 2 sine 4x. So if we simplify what we have here, we'll simply arrive at our new value, which is what? Minus 10a minus 20b cos what? 4x plus 20a minus what? 10b. This is for what? Sine 4x. Are we together? So what we simply do is we solve the what? We solve the coefficient. We solve for what? The coefficient. Are we together? Solving for the coefficient, we are going to compare. In terms of solving for the coefficient, what are we going to do? We are going to what? Compare. And if we compare, we'll simply have, comparing, we'll simply have, for the first one here, which is what? Minus 10a minus what? 20b. If we compare, this will be equal to 0. So what we do is we compare to get each of them here. So let's start with a. So if we start with a, this will be what? Minus 10a minus what? 20b, and this will be equal to 0. If you want to compare to get a, we are taking all other values to the other side. This is crossing an equality sign, and we have what? Minus 10a, and this will be what? 20 what? b. So if you want to find a, this will be minus 10, right? This will be what? Minus 10. So what we have there will be what? A will now be equal to what? We have a there to be what? Minus what? 2b. Are we together? So we can call this equation asterisk. Let's compare the next one. Comparing the next one, we have that what? 20a minus what? 10b will now be equal to what? Equal to what? 2. Remember, we are comparing this with what? 2. So if we compare this with 2, we are simply having that 20a minus what? 10b will be equal to what? 2. So if we do that, we'll simply have that what we have here will now be, remember, what is a? A is what? Minus 2 minus what? 2b. So we are replacing anywhere we see a with what? Minus 2b. So what we have here will simply be what? 20 into minus what? 2b minus 10b, and this will be equal to what? 2. Are we together? Now what do we have here? This will simply give us what? Minus 2 times this will be minus what? 40 what? b minus what? 10b, and this will be equal to what? 2. Are we together? So minus 40 minus 10 will give us minus 50b, and this will be equal to what? 2. Are we done? No, we are not done. So since we are not done, we have to get what is what? What is b? So from what we have there, we can see that our b is now equal to what? 2 divided by minus 50, and this will give us what? 1 divided by what? Minus what? 25. So this is the value for your b. So what you do is, since you've gotten the value for your b, impute b into equation x. So if you impute b into equation x, we simply have that our a will now be what? Minus 2 into 1 over what? 25. This is minus outside, alright? So if you do that, you simply have that your a will now be what? 2 divided by what? 25. Are we together? So we've gotten the value for your b, and we've also gotten the value for your what? Your a. Are we together? So what you do is you impute those values into our given equation for our what? Pi, which is particular what? Integral. So your particular integral equation will now be what? A, which is what we've gotten A, so we have that our particular integral equation, which is ypi, will now be equal to A cos what? We have A cos what? 4x plus what? B sine what? 4x. That's what we have there, right? Let's confirm that. This is A cos 4x plus what? B sine what? 4x. So since we have A cos 4x plus what? B sine 4x, we impute the values for A and B. And if we impute the values for A and B, we'll simply have that our A here is what? Minus 1 over what? 25 what? Cos 4x plus what? B is what? 2 over 25. So we have this to be 2 over what? 25 what? Sine 4x. Are we together? Now what you simply do is recall your general what? Solution. That your general solution is simply what? Your general solution is YCF plus what? PI, which is YPI. Are we together? Now if you impute those values together, we've already calculated for your CF, which is your complementary what? Complementary function. And our complementary function was given to be what? A exponential 2x plus B exponential 3x. So here you simply have A exponential 2x plus what? B exponential what? 3x plus what is now your YPI? Your YPI is given to be minus 1 over what? 25 plus what? 4x plus 2 over what? 25 sine what? 4x. So we can write this equation very well in a new page, and we simply have that our general solution, you tell your examiner that your general solution will now be equal to, what is your CF? Your CF is A exponential 2x. So you have this to be what? A exponential what? 2x plus what? B exponential 3x plus what is now your PI? We are simplifying our PI. So if we simplify our PI, what we have there as plus will be minus, because plus times minus is what? Minus. So what we have here will simply be what? Minus, not plus. So this will be minus 1 over what? 25, right? So we have 1 over 25 there minus 1 over 25 cos 4x. So you simply have minus 1 over 25 cos what? 4x, and this will be what? Minus what? 2 over what? 25 sine what? 4x. So if we rewrite this equation very well, we have our general solution to be y, and y will now be equal to what? A exponential 2x plus what? B exponential what? 3x minus 1 over what? 25 cos what? 4x minus what? 2 over what? 25, right? Let's confirm that. And that is 2 over 25. Very good. So you have 2 over 25 sine 4x. Are we together? So this is what we were asked to calculate for. Is it not simple? It's very simple. So follow the steps and get your general solution for your given equation for your second order ordinary differential equation. Please do well to like, to share, and to what? To drop a comment on the comment section. Click the subscribe button so you'll be notified when I drop more live classes like this. Thank you. Let's consider what? The second order what? ODE. What is now this ODE here? Your ODE here simply stands for what? Your ordinary differential what? Equation. Are we together? Now, when we are considering your second order ordinary differential equation, what do you consider? If you have an equation y to be equal to what? A d square y over what? Dx square plus what? B dy over what? Dx plus what? Cy, right? Now, if you have this equation, look at this equation. What is this equation telling you? This is a second order what? Ordinary differential equation. Why is it a second order ordinary differential equation? It's because the power of our differential here, the highest power of your differential, it is what? 2. That is why it is what? A second order what? Ordinary differential equation. Now, when we are considering your second order ordinary differential equation, there are some parameters we need to know. What are these parameters? The first parameter is what we call our auxiliary equation. As this course will be going on, you'll be hearing more about what? Auxiliary equation, and you need to note what is what? Auxiliary equation and how to apply your auxiliary equation. Are we together? Now, another parameter which we need to consider is what we call our complementary function. Our what? Complementary function. Complementary function, which is denoted with what? C subscript F or what? Y subscript what? CF. So any of these parameters that you see, you should know that you are talking about your what? Complementary what? Function. Another parameter which we need to note is what we call our general solution. Our general what? Solution. When can we use our general solution equation to solve? Are we together? Now, another parameter which we need to note also is what we call our particular integral. Particular what? Integral. Your particular what? Integral. When do we use our what? Particular what? Integral. And your particular integral is denoted with what? P subscript what? I, or better still, it is also denoted with what? Y subscript what? Pi. Are we together? So any of these parameters you should see, you should know that, oh, we are talking about our what? Particular what? Integral. Now, from our given equation, if we are asked to get the auxiliary equation from what we have here, auxiliary equation simply means use what you have here to represent another form of this equation. So if we want to represent another form of this equation, we can assume that your second differential, which is what? The square y over what? Dx square, will be equal to what? M square. We also assume that your dy over dx can be represented as what? M. So we have dy over what? Dx, and dy over dx can be represented as what? M. That is, it is equal to what? M. Now, what do we do to the last part of this equation? We can now say that if we differentiate cy with respect to what? X, we'll now have this to be what? If we differentiate with respect to y, you are differentiating here with respect to y. If you differentiate with respect to y, then you have this to be what? C. Now, how do you now use these auxiliary equations that you've already assumed to represent our given equation? Remember, our given equation was what? Y is equal to what? A d square y over what? Dx square plus b dy over what? Dx plus what? Cy. We want to get the auxiliary what? Equation from our given equation. So what will your new equation be? Your new equation will now be what? Y will now be equal to A. In place of the square y over dx square, we represent this with what? M square. So this is what? M square plus B, and the y over dx is what? M. So we have M here plus what? What is our cy? Our cy was given to be what? C. So this is our auxiliary equation from our given equation. Are we together? Now note, the nature of these equations depend on the final solution of our differential equation. I come again. The nature of these equations determine the final solution of our given what? Differential what? Equation. What do I mean? If you've been able to solve this, our auxiliary equation, what you do is we have three ways of representing our what solution. The first way is if, for our case 1 is if, so your case 1 is if m1 is not equal to what m2, then we'll simply have that y will now be equal to a exponential raised to the power of what m1 of x plus what b exponential m2 of x. What do I mean? From our given equation here, we were given that y is equal to am squared plus bm plus c. Looking at this equation is telling us that we have what? A quadratic equation. A quadratic what? Equation. Now, how do you solve a quadratic equation? There are so many methods of solving quadratic equation. The first one is what we know to be what? Factorization method. We factor out, right? Now, another method is our what? Formula method. Now, when you are solving a quadratic equation, your interest is to arrive at what? Two answers, which are the what? The root of that what? Equation. Now, what I'm trying to tell you is the nature of the root determines the final what? Solution of that equation. The nature of the root determines the final what? Solution of that equation. That is why I said when you have your root of the equation to be what? Two equations, and those two equations, they are not similar. When I mean they are not similar, if you have to be equal to 2 and you have your m2 to be equal to 3, you can see that 2 is a different value from 3. Are we together? So if 2 is a different value from 3, what will be the final solution of your differential equation is what we have here as your what? Your case 1. So your case 1, your equation will now be what? Y will be equal to a exponential what? m1 of x plus what? B exponential m2 of x. This will be the final solution of your given what? Equation. Now take down for your case 2. For your case 2, when m1 is now equal to what? m2, what will be the given solution of your differential equation? The given solution of your differential equation will simply be what? Y is equal to what? A plus what? B of x all exponential what? M of what? X. What am I trying to drive out? Now, from our given equation here, which is a quadratic equation, if we solve this equation and we arrive at the two root of our equation, and the two root of our equation is what? m1 is equal to 2, m2 is equal to what? 2. You can see that they have the same root of they have the same root, right? Therefore, your m1 here will be the same as your what?